Today we are going to create an audiovisual synthesizer using Max MSP. The idea of an audiovisual synthesizer is really cool. It's some kind of interface or system or computer code that does not only generate sound but also accompanying visuals. Furthermore, it does this in a way that makes sense to us, in a way we can fully customize. The certain parameters of sound turn into certain parameters of vision, and this connection creates the opportunity for all kinds of cool applications and art. So, let's see how this is done. Creating an audiovisual synthesizer from scratch is not an easy task, and that is why I'm going to do this in 3 steps. Step 1 is going to be creating a basic mono synth. I essentially just want to make a sound, create a basic synthesizer without considering the visuals, so that in the second step I can add a visual aspect to it. If I do this right, this is going to create an audiovisual feeling, an audiovisual system of mapping between the sound source and the source of the vision. This will hopefully lead into the third step, which is my favorite step, with the add poly support step. Sounds not that interesting, but actually if we add polyphony support, we can then create multiple sounds and multiple notes and multiple visual elements, making our audiovisual synth really, really cool. So let's start with basic mono synth. How can I make a basic monophonic synthesizer? Well, there are 3 components to this, right? It's actually fairly simple. I need some kind of inputs. I need something to make a sound, right? A kind of sound generator. And then I need to play this out. I need to have the resulting sound playing through my speakers, hopefully going into my ears, and then my brain will hopefully interpret those fluctuations in the air pressure as something that sounds nice to me and my friends and my family. The input is pretty easy. I'm going to create the K-slider object, an on-screen keyboard, which is going to be the main source of my inputs for this video. If you have an external MIDI keyboard, you can also use the note in object for this. Now, when I use K-slider, if you don't know the K-slider object, it's very, very simple. It sends out 2 numbers, right? So if I create 2 number boxes here and lock the patch, pressing a key gives me a MIDI note between 1 and 0 and 127, and a MIDI velocity value between 0 and 127, where 127 is pretty loud and 0 is complete silence. Now, for the purposes of this video, I will unlock this patch, right-click on the first inlet of K-slider and choose Modes. This is by default monophonic, which is nice, but I want to lock the patch, click here and choose touchscreen so that I can click and hold a note and then release it, and you will notice that releasing this gives me the same MIDI note with a velocity of 0. This is really useful because a note with a velocity of 0 will tell our synthesizer to stop playing that note. Alright, well, that's our input. Well, what is the output? It's also pretty simple, right? I can create the easy DAC tilde objects. There we go. For playing some kind of signal through my audio output device, I can also create a live.gain tilde for a volume slider, and I can make sure I'm using limi tilde with the argument 2 to use it as a look-ahead peak limiter. Now, this limi tilde is an object I use a lot in these kinds of patches because I don't know what the result will be. Maybe I will mess something up and the result will be so loud that it will hurt my ears or, God forbid, my speakers. And limi tilde is going to stop that from happening. It's going to limit the amplitude of the audio if it exceeds that threshold. Okay, so that's my outputs, and now the fun part. How do we make a sound? Well, we can spend probably like 20 videos or 10 hours or 100 hours thinking of all the ways we can make a sound in a Max MSP patch, but this is a basic monosynth, right? So I'm just going to take a basic oscillator object, try tilde, and I'm going to simply use this as the sound source. I can even visualize what it looks like to you. If I give it the argument 5, then it's going to generate the sound at 5 Hertz, a frequency of 5 cycles per second. And I can not hear this, but using live.scope tilde, I can connect it here, lock the patch and turn EZDAC on, and then I can see that, well, here are my beautiful triangular waveforms. Right, there are a lot of cool details about these kinds of oscillators, but for our purposes of a basic synth, this will make a nice sound. Okay, so I need to take this. I don't need to give it an argument because I will determine its frequency myself. I'm going to determine its frequency by sending it a message from my input system, my K-slider object. The only problem is that this sends out a MIDI note value and I need a frequency for an oscillator. So I'm going to use the M to F MIDI to frequency object in order to convert this value into, let's see, a frequency. Right, so now I know that a MIDI note value of 62 is actually a frequency of 293.664768. According to this, and who am I to doubt what holy M to F is telling me? All right, now how does this sound though? There we go, turning up the volume slider of live gain tilde, I can now hear the output of my beautiful synthesizer. Right, now this works pretty well, but it's monophonic and it's a basic synth, but I also want to be able to trigger notes, right? I want to be able to press my finger on the key and have it trigger a sound, and I want to be able to release my finger from the key, and I want the sound to fade over time. So I'm also going to create an ADSR envelope, also called an amplitude envelope. Right, and what I want to do is to describe how the amplitudes, quote-unquote loudness of the sound, evolves over time. And I'm going to do this by using the ADSR tilde object. It's going to be very useful in making synths in Max MSP. You might know that ADSR stands for attack and decay and sustain and release, and it essentially is a description of how the amplitude will evolve in 4 steps. So these are going to be the 4 arguments to the ADSR tilde object. How much time does it take in milliseconds for me to go from complete quiet to the highest amplitude when I start playing a note? This will be in milliseconds. I will make it 150. The more this is, the larger this number is, the longer it will take for the sound to completely initiate. And the shorter it is, the more sudden the attack of the sound is going to be. Now, decay is the same thing, but it's instead how much time does it take in milliseconds for me to go from the highest amplitude to a lower but a more stable amplitude. Let's make this 50 milliseconds. Third one, sustain, is not something in milliseconds, not a time measurement, but a measurement of amplitude between 0 and 1. 0 is complete silence, 1 is the loudest sound my system can make, and what is the amplitude when I'm holding my key and I'm just holding on to the note, I'm holding and sustaining the sound. Let's make this 0.8, 80% of my maximum amplitude. And finally, release is how long does it take in milliseconds for my sound to go away, for it to fade away and end. And I like to make this long, I'll make it 2500 milliseconds, aka 2.5 seconds. So also write this down here. And there we go. So once I have done this, once I have defined my ADSR envelope, right, I am going to receive some kind of signal. Now, this is not going to be a signal I can hear or I'm supposed to hear. I think it will sound horrible or make a bunch of clicks and pops. But instead, this will change when I send a number larger than 0 to ADSR, and it's going to go down once I send ADSR the message 0, right? A non-zero number, trigger the envelope and stay on sustain. A 0 message, slowly go to this value of 0. This signal is something we are supposed to multiply by the sound source, the actual audio, whatever's coming out of our oscillator. So I'll take try tilde, use the multiplication tilde object to multiply signals, and I will multiply it by whatever comes out of ADSR tilde. There we go, look at this, it's beautiful. And now I can turn on my volume. I'm not going to hear anything because my envelope is at release, but now I can trigger and let go of the sound. Trigger it and let go. Of course, I don't want to click a toggle over and over again. So what I'm instead going to do is I'm going to take the MIDI velocity, which is between 0 and 127. I am lazily going to use the scale object to take this range of values between 0 and 127 to a range between 0 and 1, and then plug that into ADSR tilde instead. Now, this is going to be really useful because then the volume, my velocity, will affect the size, how loud my amplitude envelope is. So check this out. A quiet note is a quiet envelope, and a loud note is a loud envelope. And that's all by doing this little trick. Great, so we have created a basic monosynth, so I can write done here because we are done with the first step. Now, how are we going to add a visual aspect to this? Now, this is where things start getting really fun, right? And if we are thinking on a basic audio-visual level, I think a great trick we can do, well, not a trick, but a great perspective we can have, is to take all these parameters of our synthesizer, right? The pitch, the velocity, how the ADSR evolves over time, I don't know, different parameters of the ADSR envelope, and so on, and translate those into parameters for some kind of visual system. And don't be scared when I say visual system, this can be very basic. So I'm now going to create some kind of visual representation system so that I can modulate its parameters through whatever is happening in my basic mono synthesizer. So let's think 3D. I'm going to create a jit.world object and I'm going to give this a name. This can be anything. It can be tomato or potato, but I will call this cool synth because I think my audiovisual synth is going to be pretty cool. I will also give this the attribute floating and set it to 1. I will also give it the attribute FSAA, full scene anti-aliasing, and set that to 1 as well. So now my jit.world window is going to be floating in front of my max patch, and a full scene anti-aliasing filter will be applied to it, making the visuals a bit nicer looking. When I do this, I need to create a toggle and connect it to jit.world, lock the patch, and turn the toggle on so that my jit.world is running. It has to be switched on. When I do this though, right? When I do this, I can then create an object called jit.gl grid shape, and I can give it the argument of my jit.world context, cool synth. Doing this without me having to connect this to anything is going to make a shape appear in my 3D visuals window. It's a bit large though, and we can change certain aspects of this by sending this object a bunch of messages or changing its attributes, right? So I can give it a scale attribute and set it to 0.25 and it will be immediately much smaller. But I can do the same thing by sending it messages. Pack scale 0 is a very good way of doing this. The first inlet replaces scale. We don't want that. The second inlet replaces the 0. And we do want that, and doing this lets us control the size of our 3D shape. I can also change the shape of this, right? If you really want to get deep into this object, you can always check the help file and the reference of jit.gl grid shape. But for now, I will make the shape a plane. Unfortunately, it doesn't turn into an actual plane, the vehicle, but it turns into like a nice sheet of paper, which I find also really useful in audiovisual contexts. I can further change, let's see, well, the color, right? Pack color 000. Each number is an amount of a certain component, amount of red, amount of green, and amount of blue, all being between 0 and 1. Right, so I can, for instance, connect 3 float number boxes here and make it more red, add some green, add some blue, really do a bit of color alchemy myself and create these shapes of different colors. I can further change the position, right? So pack position 000, and these are always going to be on 3 axes. The x-axis, the y-axis, and then the z-axis that's farther from you and closer to you. The trick with the position and any kind of coordinate system in the jitter world is center is 0, 0, 0, right? So every time I deviate from 0, I'm either going right or I'm going up or I'm going, let's see, closer to the screen. So I can There we go. Change the x-axis, the y-axis, and the z-axis of my shape. There's a lot more we can do, but let's just take the things that are relevant to audiovisual applications. So let's change, let's give it a rotation. Pack rotate x, y, z, and 0, 0, 0, 3 zeros. So rotation is going to be expressed in degrees. Rotation around the x-axis, rotation around the x, y, and the z-axis. Right, and finally, let's add, I don't know, some kind of transparency. Yeah, that's cool. Let's add some transparency to our visual shape. So I will give this another attribute. I'm just going to hard code this in. Blend underscore enable set to 1. Now, on its own, this blend enable 1 doesn't do anything, but it lets us add a 4th number to the color message. Right, so now this color message is not merely RGB, but it's RGBA, red, amount of green, amount of blue, and the alpha, 0 being completely transparent and 1 being very, very visible. Okay, so if we want, now we can start, well, assigning some of our synthesizer parameters to whatever is happening here. Right, so all these numbers can and should be controlled by the parameters of our basic mono synth. So let's take something, to me, very intuitive. I want the shape to fade in as I start playing the note, and I want the shape to fade out as the note itself fades away. So I want the alpha, or the opacity of my shape, to follow the amplitude envelope, right? Just one of a million possibilities we can do in such a setup. So how am I going to do this? Well, I have a signal here. I can't really take a signal and plug it here. Look, I mean, Max doesn't really let me do this, and smart for doing this, but I can convert the values of my ADSR envelope into numbers by using the snapshot tilde object. I'll give it an argument 33, meaning every 33 milliseconds, convert the signal to a number. And now, as you can see, I have my amplitude value, right? So I can send this. I'm going to use the send object here, and I can call this synth amp, right? And then I can scroll here, create the R, synth amp, so I can receive that value. And now, as you can see, it's 0. And now when I play something, it's going to fade in, and if I release it, it will slowly fade out. Beautiful. But it does require a bit more variety, right? And if we had a lot more time, I mean, I can make this video 5 hours long, but I don't think a lot of you would watch this if this was 5 hours long. If we had that much time, we could really craft intricate systems to determine the color and the position and the rotation of my shape, depending on the pitch, the intervals, the sequence of notes, the frequency, the velocity, and some other parameters. But to make things easier for now, for demonstration purposes, I'm just going to randomly trigger colors, positions, and rotations as I input a note, right? So each time I trigger a note, I want to trigger a new color, a new position, and a new rotation. So I'm going to use a random object a bunch of times with giving it the range attribute. For color, this can be between 0 and 1, right? So amount of red, random between 0 and 1. Amount of green, random between 0 and 1. And guess what? Amount of blue, also random between 0 and 1. There we go. Sending a bang to these is going to trigger new values for my color. Now I can do the same. We need a bit more real estate space here, don't we? I can do the exact same thing for position, but I know the center of my stage is 0, right? So my random ideally should go between something like 0.5 to minus 0.5 to plus 0.5 for the X and the Y axis. I'm not going to touch the Z axis for now. So now each time we're going to get a random position for our 3D shape. And finally, for a rotation, I said this works in degrees, so let's make this go from 0 to 360 degrees. Right, there we go. Another connection here and another connection here. And again, I can simply trigger this by using a simple bang message, a simple button. Right, so now, for example, I can have a shape like this. It's gone. I'm going to refresh the position, rotation, and the color, and trigger another shape, and so on. Now, of course, I don't need to click this button over and over again, and this is something I should automate. So the question becomes, how can I trigger a bang when I start playing a new note? And luckily, we can, again, we are doing this a lot, we can turn to our lovely friend ADSR tilde. Because ADSR tilde has this cool third outlet, which is a mute outlet. It might be useful a bit later in this video. But right now, all you should know, all you should consider is that this third outlet of ADSR tilde sends out the message mute 0 when I'm playing a note. And when the note is completely released, it will send out the message mute 1. Now I can do a nice trick here. I can create the object route. I can type in mute. And then this object is going to give me either 0 if I am playing something and 1 if I'm completely done playing that note. So I can take this a step further by using the cell, short for select object, and type in 0 so that each time I get 0, so each time I start playing a note, cell sends a bang. I will receive a bang message. So I can make another send object and call this new note. Right, so now bang is going to go into the send object called new note, and I can have a bunch of receive objects called new note, and they're all going to trigger the random color, the random position, and the random rotation. Right, so check this out. But each note I'm having a different color, a different position, and a different rotation. Okay, this is really fun. I love doing this stuff. Like when I create audiovisual compositions myself, I actually do this a lot to figure out which kind of audiovisual system I'm going for to be creative in. So I just want to take another minute to add, let's say, one more thing. Right, and I first want to demonstrate what I'm going to do. So I'm going to forcefully make this shape more visible because I want to add to this JIT grid shape object a new object, so something new called jit.anim.drive. If I connect this object to JIT grid shape, nothing really is going to take place except I can send this JIT.anim drive certain messages to animate my 3D object. Right, so I can send it a message, for example, turn, and then 3 values representing how quickly or how fast something should spin around its own axis. You will notice that my object is slowly rotating. Right? Amount of rotation on the x-axis, the y-axis, and the z-axis. And if I want to make this stop, I can send it the message turn 0, 0, 0, and it will stop turning. Now, what I would love to do is to automate this by making the speed of the rotation something dependent on my velocity, how loud my note input is. So let's do a little trick. Pack turn 0, 0, 0. But actually, pack without a C. Pack turn 0, 0, 0. Right, and then I'm going to take a single float value, but I'm going to make this the amount of rotation on the x, y, and the z axes. Right, because I don't really care about the specifics of the rotation. Right now, I just want to make it rotate at a certain speed, here determined by these float numbers right here. Okay, now I want to get the scale here, or whatever I get from scale, so a normalized velocity, right? MIDI velocity between 0 and 127, normalized velocity between 0 and 1, only that I don't want the zeros, right? If I release my finger, I don't want this to turn into 0 and send the rotation 0. I just want this to get the non-zero value, and I want to send the non-zero value to my turn message right here. So we can do this in a few ways. I think what I'm going to do is to use the split object with the argument 0. This is a nice little trick. If you want to eliminate a lower or a higher bound, you can go to split, give it the value 0 in this case, and the second outlet will only give you the non-zero values, right? So 0.701, 0.11811, or 0.551181, a lot of 1s and 8s, doesn't matter. We are filtering out the zeros, which is fantastic, and which means that I can now take this value and I can again create another send object, so you can see how fast this can get out of hand if I'm not patching things neatly, and call this note vel, right? Short for note velocity. And I'm going to create a receive pair, and I'm going to plug it into here. Now, the only thing I want to do is I also want to now go to my route mute select 01 part of my patch, right? The thing that's connected to the third outlet of the ADSR tilde object, and also select 1, right? So now this becomes cell 01, because I also want a bank once the amplitude has stopped playing, so that I can send this with the name note or end note, right? New note, end note, so I can receive our end note and use that bank, use this bank to trigger to send the message turn 000 to JIT drive, stopping the rotation of my 3D shape. Lovely. Okay, finally let's add a few more pieces of visual sugar. Don't worry, this is not going to take long before we go into the poly support. Oh yeah, I should also connect the, there we go, the alpha value, right? I on purpose disconnected this. That's more like it. Okay, now I want to do two things very quickly. I'm going to go to the jit.world and I will add the attribute, what was it called? Erase underscore color. This is essentially the background color of my jitter world. I'll set this to 000 so that even when my jit.world is on, the background is black. Right? I just think this looks cooler. And black background in audiovisual works almost always work. They don't always work. It's always context dependent, but it's usually good enough. And secondly, I will do a little trick. I don't know if you have heard of this object before, but I will use a beautiful object called JIT-GL Pass. Right, and this is going to add some visual effects to my 3D scene as it comes out of my jit.world window. I just need to give it the cool synth name, and I can then right-click the inlet and then choose, let's see, FX name, and then I can click here and I can choose all these different effects. Right, so if you're interested in this, if you want to play around with this, check it out. But I am going to use, let's see, FX name motion blur. And what it does, is, if it works, right? Let me see, FX name motion blur, and then I'm going to go to, no, it's motion glitch. Apologies, FX name motion glitch. So my brain is glitching out thinking about these FX names. There we go. It adds these little glitchy visuals, these glitchy effects to your visuals. So after you add this attribute, you can right-click the inlet. You can choose, I think, two attributes that are interesting, which is FB underscore amount, the feedback amount. I like to set this to something like 0.9. And noise amount, again, I like to set this to something like 0.85. And if I do this and I play my audiovisual synthesizer, I'm going to get all these beautiful glitchy visuals. We can even go higher than, there we go. Oh, okay, that's a bit too much. Okay, so don't go higher than 1, with the noise amount unless you want to create some really wacky noise effects. Beautiful. Okay, so we did add a visual aspect, right? So now this is officially an audiovisual synth, but I think to have this battle ready, we have to also add some kind of polyphony here. But for now, let's just add a beautiful done to our second step. Okay, so how are we going to add poly support? Now that's an entire can of worms on its own, right? How to do polyphony, how to make polyphonic synthesizers. But I think based on what we have, we can easily create a polyphonic version of this. Now, here's what we need to do. Step one, we need to save our patch as some kind of main something.max path for future reference. Right, here I'm going to replace it. Step two, I'm going to create a new patcher. Right, it's a new patch, and I'm going to save it as something like audiovisual synth patch.maxpath, right? Audiovisual synth patch.maxpath. You can call this anything you want. It just should have a name, and it should be saved in the same folder as your main patch. That's the important part. Now, here is what we want to do. In my main patch, I want to take anything, or everything actually, I want to take everything that is not an input and everything that is not an output, right? And I want to cut and paste it in my new empty patch, right? So I'm going to not take case slider, but I'm going to take all these guys in, but I'm not going to take live.gain, that's a part of the outputs, right? So I'm going to then scroll here, and I'm going to further shift, click, and drag everything here except jit.world and jit.gl pass, because those are about the visual outputs. I'm going to cut these. Now look at this patch. It's all tiny and sad again, but don't worry, I'm going to paste these in my audiovisual synth patch. All right, now I need to do a few things to prepare my polysynth before it is ready to be played with. And the first thing I'm going to do is to add some input and output objects. Well, these are called in and in tilde, and out and out tilde. What I will do is I'm going to create in and give it the argument 1, as in this is the first inlet, and this will contain the MIDI note and the MIDI velocity as a list. So I need to unpack 0, 0 to separate the incoming list. There we go. Then when my audio is being sent out, I'm going to use the out tilde object with the argument 1. Boop, there we go. So that it is sent out from our polyphonic synth. I don't need to do the same thing with my jitter visuals, because remember, jit.gl grid shape does not need to be connected to anything. Let me think about this. I do need to do one more thing though. When we are thinking polyphonically, when we are thinking in a polyphonic fashion in Max MSP, it's dangerous to have send and receive objects just laying around like this. We need to give all the send and receive object names the number sign, 0, and underscore. Right, underscore is actually not necessary, but number sign 0, underscore, note well, number sign 0, underscore synth amp, and so on. Now, what this is going to do is that it's going to turn into magically a unique identifier when we are working polyphonically, because what we are going to do is that we are going to have multiple instances of this new patch running, right? This is going to be our key to polyphony. We are going to make it so there are 2 or 5 or 10 or 20 of these patch technically open at the same time, so that when we play a new note, we can play another note on top of it without interrupting the previous note. This is going to be how we achieve polyphony. And for audiovisual stuff, this creates a cool opportunity, because it would mean that there would be 2 jit.gl grid shapes, or there would be 5 jit.gl grid shapes, or there would be 20 jit.gl grid shapes, all individual images that could, in theory, appear together. So I'm going to save my audiovisual synth patch.maxpath. I'm going to go to my main AV synth patch. I'm because now I can introduce a magical object, which is called poly tilde. Right? This is going to manage what the process I just described to you. It's going to take, what did I call it? See, my memory is so bad. Main AV synth, no, audiovisual synth patch.maxpat. I just keep forgetting these patch names very quickly. So I'm going to give poly tilde the arguments as the name of my patch, audiovisual synth patch. And then I will give poly tilde a second argument. How many instances do I need? How many sounds or notes or visions do I need to experience at the same time? And let's like make it 10. Right? Well, look at what happens. Suddenly a shape appears here because now we created 10 of these JIT-GL grid shape objects. Right, so now if I want to, I can take the output of poly tilde, which you will notice is, there we go, a signal, and I can pack my MIDI note and my MIDI velocity, and I can use a very specific message to send this, my MIDI note and MIDI velocity, to poly tilde, and that is the, let me see, the message MIDI note, right? So prepend this with MIDI note. I need to do this, and if I do this, the note on and note off messages of my poly synthesizer will be managed correctly. Right? So the right instance out of these 10 possible instances in my poly tilde here are going to receive the correct note on and the correct note off information. In fact, let's try it. Beautiful, look at this. Now, if you have sharp eyes, you notice that there are these weird shadows, these black outlines that are not the shapes that we are showing, but they're there nonetheless. And that is because even though our shapes are completely transparent, sometimes it happens that like they are still processed by the vision, so the off notes, the off visions, the visions we are not, the shapes we don't need to see still appear here. So let's do a final fix. Let's again open our audiovisual synth patch.maxpat, and let's give this JIT-GL grid shape object enable 0, the attribute enable 0. What this is going to do is that it's just going to disable the entire shape. We are going to see nothing. This will not appear in any way or form in our 3D visuals, in our jits.world window. However, well, we have our zeros and ones here, right? We can turn this object on, enable 1, send it the message enable 1 when we are supposed to see this, and we can send it the message enable 0. I know there are better ways, more streamlined ways of sending these messages, but just to show you, we can send enable 0 once the note is done playing. And we do have a new note bank, which should go here. And we do have an AND note bank, which should then go to the enable 0 message box, right? So we are triggering enable 1, the note starts playing, the amplitude envelope is over, the note stops playing, we send an enable 0, the 3D shape is gone. So I can now save this patch, I can recreate my poly tilde object, and now it's going to be perfect. Amazing. The only step after this is to simply add more visual and audio effects. Right, so for example, I can use a, let's see, ABL DSP phaser. Right, this is one of those like cool new Max 9 objects. So I can use the Ableton phaser algorithm to spice up my basic synth sound a bit more. I can further add some reverb, abl.dsp.tides. The tides algorithm reverb is really cool for this. Let's do it like this, there we go. And we get a completely different and beautiful sound. Similarly, I can explore and chain other JIT-GL pass algorithms, right? So I can create another JIT-GL pass, cool synth. I can give it the effects name, Bloom HQ. I just noticed off the top of my head. You can always explore different effects names and effects for JIT/GL Pass. And I can do this little cool trick where I take the second outlet of my first JIT/GL Pass and connect it to the inlet of my second JIT/GL Pass, essentially creating an effects chain. I'm then going to change the threshold and let's see, the bloom amount. There it is. The bloom amount attributes, lower the threshold, lower the bloom amounts, and let's see how this looks. It's completely dark. Why is it completely dark? Did I mess something up? Nope, it should be good. There it is. Now we have some beautiful bloom effects in our visuals as well. And this is just the beginning, right? Once you have created your audiovisual synth, you can keep adding different sound effects and audio effects, other visual processing effects, but eventually you can always create things with your audiovisual synthesizer. This becomes an instrument not just for your ears, but also for your eyes, and I find this beautiful. I hope this has been interesting to you. I hope you create something really cool using this, and as always, thank you for watching.